Hello everyone. Welcome to the first of our bi-weekly knowledge sharing sessions. I am Jayant, and today we'll be diving into something very foundational, yet something which is often overlooked when building with LLMs, and that's evaluations. So whether you're shipping rack pipelines, whether you're shipping like prompt-driven agents or like customer-facing chatbots, evals are the sanity checks that will tell us like what is actually working and what is not working. So why do we even need evals, right? Like LLMs are powerful, but LLMs are also unpredictable. Like they hallucinate facts, they often drift in behavior across time, and sometimes they make errors that can damage the trust or the brand or even expose the organization to legal risk. And without evals, you're basically flying blind. And because imagine if your dev team deployed every major feature with zero unit tests. Like that is how majority of the LLM applications today are being launched. And there is no safety net, no signal on when things break. And because of that, the effects are very real. And let's look at some data now. So looking at these numbers, you can see like in one study, LLM code success rate dropped from 52% to 10% over 3 months. The same prompt, but a different version. Even like math performance, which you'd think would be consistent, dropped from 84% to 51% in a matter of weeks. And this is what we mean when we say LLMs are non-deterministic. Like this is why we need evals. So even if you're using OpenAI, you're using Anthropic, you're using Minstrel, you can't just set it and forget it. These models drift and their outputs they vary across temperature settings. So if you care about stability, if you care about quality, we're going to need a consistent way to measure them. So let's make it real for the business side. Like why should we even evaluate, right? We care about which LLM is the best for our needs. We care about the user experience. We care about cost efficiency. We care if the tone, style, and safety are in line with our product. And we want to know what broke and when it broke. So they're not just about scoring. Evals are the feedback loop which lets you improve. So what is an eval? Let's think of it like a structured test. Like just as we test software with inputs and expected outputs, we test LLM using prompts, datasets, and scorers, right? The key is to turn these vague quality into measurable signals. So now comes the question, what's even the difference between evals and test cases? What's the problem if we just take this prompt response pair, as I have shown in this slide, and we just put it into a if else test case and we just run the case? Can anyone answer me?
Okay, I was on mute. Sorry, I missed the last line. Can you please repeat it again?
Yeah, what's the problem with just writing test cases like this? So, say to ChatGPT, I gave this prompt as a new founder, give me three key steps to launching a tech startup, and it gave me this response. So, why can't I just take this, put it in a if else case, and then just, run the case? What's the problem?
Okay, interesting. Don't know. Can't think of it now.
Yeah, the problem is non-determinism. We won't receive the same output even from the same model with the same prompt. Like you tell the same model, the same prompt of write a hilarious poem about how startups fail because of the same reasons, and the answers will always be different. So how do you even begin like evaluating this? So the first is the task. This could be a single prompt or the entire agent workflow. The second is the data set, the set of real world examples that we use. The third is the scorer, that the logic which decides how well the LLM did. And together, this gives us a score between 0 to 100 for each test case. So when you zoom out, this is how the structure looks. You have your input and your model output, and after that you have a scorer which scores that output. And based on that output, if it passes a threshold, it either pass or fail. So there's two ways to do this. We can either use online or offline evals. Offline evals are the ones which happen before deployment, like a test suite for prompts or agents using sample inputs. And online evals happen after the launch. So offline is great for like regression testing. Online is the real world radar. Ideally, you want both, but even starting with one makes a huge difference. So let's talk about what we actually measure. These are the core eval metrics that you'll see, like answer relevancy. Is it useful and on topic? Is the answer factually correct? Did the model make something up? Did the agent call the right tools for it? Is the contextual relevancy there? Did it retrieve useful info or did it retrieve useless info? Is it safe? Is it inclusive? So you just have to pick the ones that match your business goals. You don't need 10. You can just do with like three of them. And while most of the metrics are generic, they're not sufficient to target specific use cases. So for those, we'll need at least some custom tasks specific metrics. And these metrics are going to be designed by you. So how can you design something that is great? For example, if your LLM application is designed to summarize pages of news articles, you need a custom evaluation that scores based on whether the summary contains enough information and whether the summary contains any contradictions or hallucinations. So, how do you make your custom evals? You always want your metrics to be quantitative so that they always give you a score. You want them to be reliable. So, they should be more or less consistent with the scores that they give, and they should be accurate. Reliable scores are meaningless if they don't represent the performance of your LLM. Your score should line up with what humans actually think of your output. Now, here we can see the Venn diagram of a couple of different ways to compute metrics. We on this side we have the dumb statistical scorers. You'll soon know why I call them dumb. And here we have the context-aware model-based scorers. So we're going to start with the dumb ones, and then we'll proceed to the model-based ones. Let's start with the most basic scoring approach, statistical metrics. These scores don't understand the meaning. They just overlap between the output and the reference answer, and they see the overlap. So they're fast and easy to run, but they don't really work well for reasoning tasks or for long form answers. Think of them like spelling checkers. You'll They'll know what looks similar, and they won't know what makes sense. But before we dive into stat scorers, let's talk about n-grams. So this right here is a sentence, and n-grams is just this n is the number for the n-grams. So if you're talking about unigrams or 1 grams, this is a sentence. All of these four are unigrams. If n equals 2, then this is a sentence. All of these are bigrams, and you get the point. So most statistical scorers use these n-grams to measure the similarity. And here are the three top n-gram based stat scorers that you'll hear about. So blue is precision focused. It is great for translation, and it looks at how much of the output matches the reference. Rogue is recall focused. It is often used for summarization. So it checks how much of the reference is captured in the output. And Meteor combines both of these and then adds synonyms and word order. It is a little bit more nuanced, but it still doesn't understand the text. Bottom line, all of these are surface level and they're helpful for quick comparisons, but they're not reliable for complex tasks. Another one is Levenstein distance. If you've done lead code, you'll recognize this. It counts how many edits are needed to turn this one string into another string. So this is useful for catching typos, but it's not very helpful when comparing meaning. As you can see, stat scorers fail to understand the reasoning or the semantics, and that's a deal breaker when you're evaluating LLMs. So moving on from these stat scorers, we'll move on to these model-based scorers, starting with these two. Um, so these scorers use smaller models to score LLM outputs. For example, NLI scorer it checks if your output logically matches a reference, and then it returns entailment or contradiction or neutral. Blurt combines BERT readings with training data to predict how close an answer is to a good one. So These are a little bit smarter than n-gram metrics, but they're still limited. You'll see that, especially when handling nuanced or long answers, they don't match human judgment well. But uh, you've guessed, like all of these and these are missing one key point. Like there's one more thing that we can do to evaluate LLM answers. Can you think of one?
I think these metrics doesn't scare the contextually and semantic relations between the words, right?
Yeah, but what is the one thing that one way that we are missing? There is one more way that we can do this. Like I'll
You
give
mean
you
in
a hint.
terms of reference, or because these
No, in
are
terms of
so far we
methodology.
have figured out it's almost like a
In terms of
supervised.
what?
Methodology. Like I'll give you a hint. Iron sharpens iron.
Which one?
Iron sharpens iron. लोहे को लोहा काटता है.
Okay. Using LLM again, right?
Exactly. You can use LLM as a judge. So now we've
Okay.
reached the gold standard. Like this is what most of the evals use. So this is when you use a model like GPT-4 to judge another model's output. And this is currently the most accurate way that we have to score tasks. You'll hear about frameworks like G-Eval or DAG and some models like Prometheus, and all of them they use LLMs to apply evaluation to get an answer. So let's look at G-Eval first. This is a method when you can give ChatGPT a rubric and then you can ask it to grade outputs. And you can use this for many tasks like checking factuality, evaluating tone, or judging creativity. So G-Eval works best when your metric is subjective, like quality or clarity, and there's no one correct answer. It like as we can see here, it first generates a chain, like a series of evaluation steps using chain of thoughts before it generates steps to determine the final score. So, for example, let's run through the algorithm quickly. Let's introduce an evaluation task to the LLM of your choice. Let's say, and we rate this output from 1 to 5 based on coherence. So, give a definition for your criteria, like coherence is the collective quality of all the sentences in the actual output. Now, after generating a series of evaluation tests, it will create a prompt by concatenating the evaluation steps with all the arguments. And at the end of the prompt, we can ask it to generate a score between 1 to 5, where 5 is better than 1. And because of this, like G-Eval is really great because as an LLM eval, it is able to take in the semantics of the outputs and it is much more accurate because like how can like think about it, how can non-LLM evals which are using scorers which are far less capable than LLMs possibly understand the full scope of a output generated by the LLM, right? You need a LLM to evaluate the output of a LLM. And G-Eval is great based on the case where subjectivity is involved, but if you have a clear success criteria, like you want to use a scorer that is decision based, uh, you can use DAG or deep acyclic graphs. So imagine this, you have a text summarization use case where you wish to format a patient's medical history in a hospital setting. You'll need various headings in the summarization in correct order and only assign it a perfect score if everything is formatted correctly. In this case, where it is extremely clear what you want, you can use DAG. It's a decision tree and it is powered by LLM as a judge, where each of the node is a LLM judgment and each edge is a decision. The final hard-coded score is returned, and as you can see here, like using the decision tree, it calculates whether uh, all of your outputs are according to something, and it gives you the score. Another one is Prometheus. So Prometheus is specifically open source designed LLM, specifically designed for evaluation. It uses Llama 2 as a base model, and unlike G-Eval, where it uses ChatGPT 4 to generate, Prometheus needs you to feed it explicit rubric and reference answers. So it needs you to tell what it has to evaluate. It's a little bit more manual, but the results are more reproducible, and it is the best of them all. So I guess enough of the boring stuff. How many people know who this guy is? Hello?
Yeah, I think everybody knows.
Yeah. So who is this?
What I know interesting about it, like his body fat index, it was just 6.5
Mm.
or
So this
8.5, something
is
like ultra.
yeah. So this is a picture of Bruce Lee. But Jayant, why is there a picture of Bruce Lee in my slideshow? This is partially to catch your attention in case you were sleeping, but also to show you a point. So, in his early life, Bruce Lee began his martial arts journey by training with Wing Chun under the tutelage of Ip Man. And yes, this is the same Ip Man with on whom this movie is made, starring Donnie Yen. So, this is the real Ip Man, by the way, and this is Bruce Lee beside him. So, his experience in Wing Chun taught him that many traditional forms were too rigid and too impractical. So this is why Bruce Lee wanted to develop his own martial arts philosophy, which he called Jeet Kune Do, the way of the intercepting fist. And he wanted to create a system which is not bound by a specific system, but it is focused on effectiveness and using no way as a way, having no limitation as a limitation, is the core tenet of Jeet Kune Do. So what does this have to do with LLM evals, right? Now that you've woken up, we can discuss how it relates over here. So these two methods, the statistical scorers and model-based scorers, they generally use only one way, but we don't have to be confined to one way. We can combine all of these and we can make custom rubrics, right? So in these, as you can see over here, we have all of these, and we'll start with bird score and mover score. So compare instead of comparing the raw text, BERT score uses cosine similarity. It uses BERT, of course, and using BERT, it uh, calculates the cosine similarity between your output and a reference. And mover score goes further than this, and it calculates how much semantic effort it takes to turn one sentence into other. As you can see, these are more context aware than blue or rouge, but they still fall short when it comes to reasoning or logic. But they're a decent middle ground and they're faster than LLMs. And to recap, each of these has a trade-off. Stat scorers are very cheap and reliable, but they're very dumb. Model-based scorers are flexible, smart, but they are expensive. And embedding-based scorers, these ones, are more semantic, but they are still limited. So, what if we could have the reasoning power of the LLMs without directly asking them to score the output? So this is where QAG comes in. QAG stands for question answer generation, and this is a very clever way to evaluate factual correctness. So how it works is you use a LLM to extract all the claims from an output. Then you convert each of those claims into a yes or no question. And then you ask the ground truth if it agrees with the output that has been given. And then using that, you calculate a score. This is especially neat because you're not asking the LLM to rate itself, you're just cross-verifying with a trusted source. We'll see it with an example. So, the model outputs that Martin Luther King Jr. was assassinated in April 4, 1968, right? So, you extract each of these claims in this. So, one of the claims can be MLK was assassinated on April 4th, 1968. Now, using those claims, you turn them into a close-ended question, a yes or no question. So, was MLK assassinated on April 4th, 1968? And you do this for all of the claims. And then you compute how many of them matched. And using this, you can get your faithfulness score and you can see how many hallucinations the model is actually getting. Let's talk about GPT score next. So, this is a scoring model based on top of GPT itself. Instead of manually checking or comparing n-grams, you give GPT a structured rubric and let it evaluate its answer against a reference. So it's sort of like G-Eval, but it's tuned to score for more specific tasks like summarization quality or fluency. And you'll use this when you want a human-like evaluation, especially when you have subjective output, just like G-Eval. And there's one more idea which is called self-check GPT. So this method asks the LLM to generate multiple versions of the same answer, and then you check for consistency in between them. And why do we do that? Because if a model keeps changing its story or if it keeps contradicting itself, it's probably not grounded in fact. So if you ask five versions of GPT to answer a question and three of them contradict the others, you have a red flag. And this variability is a sign of hallucinations. This is particularly useful when you don't have the ground truth and when you want to detect instability in your outputs. So we've covered a lot of scores by now. Let's wrap up this section. You should always treat your scorers like judges. You should give them clear instructions. You should ask focus questions and you shouldn't have any distractions. Obviously, the judges will come up with slightly different scores for all of the same things, like diving judges who come up with a different score for the same dive seen from the same angle, but all of the scores are different. But still, you can see like all of the scores are close, and you can see a ground truth when you average all of the responses. Also, use a stronger model for scoring. If you generate with GPT 3.5, use GPT 4 to judge. Break down scoring into multiple metrics. Don't just lump everything into good or bad. Test scoring prompts on the playground first and avoid stuffing scorer prompts with too much context. Keep it focused, keep it clean. But by now you must be thinking like all of these metrics, how do we choose between them? Like, do we really need all of these metrics? Do we have to get like 10, 20 metrics? And the answer is no. Trying to track everything usually leads to confusion. You'll spend more time reading scores and less time improving your output. So, what matters is you choose the right metrics for your use case and just tune those. Um, Here's the framework that works well. So, pick one or two custom metrics. This could be like, did the output match our tone or was the advice practically useful? Then pick two to three system level metrics depending upon your app type. So for RAG systems, look at context relevance. For agents, stack tool usage. And for chatbots, look at coherence. And as you can see in the flowchart here, you can choose your metrics based on what you value most. And after this response, you can validate the scoring and you can keep iterating until you're satisfied. So at this point, you're wondering, okay, so I got my scores. So what should I improve? Should I improve my evals or should I improve my application? So this is a very simple rule of thumb. So if you have a good output, so a human reads your output, a human says, okay, this output is good, and you have a high score, congratulations, like everything works, you can celebrate. If you have a good output, but your score is low, so the system is scoring it low, you need to check your evals. Similarly, if you have a bad output, the human is saying that this is trash, but you have a high score, you need to improve your evals. And finally, if you have a low score and a bad output, your eval is working fine. You just need to improve your application. So let's talk a little bit about RAG metrics. I'm sure all of you know what RAG is. Think of them as chatbots that look up stuff before answering. So instead of relying on the model's memory, they retrieve info from some knowledge base. Um, so now we have to evaluate not just how well the context was retrieved, but also if the model used the knowledge correctly. And for this, the first and most important RAG metric is faithfulness. Faithfulness asks, did the model's output stick to the context that it was given, or did it make stuff up? So step one, you extract factual claims from the output. Then you check if each claim is supported by the documents. And then you score based on how many claims were verified or they were at least plausible. And this helps us catch hallucinations. The second drag metric is answer relevancy. Did the model actually answer the user's question? Sometimes the model tends to ramble or over explain and goes off topic. We can measure this by counting how many sentences directly address the query. Next up is context precision. It evaluates how well the retriever prioritized good content. So in RAG, retrieval pulls chunks of text from the knowledge base, right? But if it brings you the right info at the bottom and irrelevant junk at the top, the LLM is like it'll tend to ignore the good stuff. So this metric checks if the relevant documents appeared early, and because the early appearing documents are where the model pays attention. Then there's contextual recall, which is the flip side. It asks, did we retrieve everything that the model needed to answer the question? Like we compare the expected answer to the retrieved documents, and then we score how much of the answer was actually supported by the documents. And finally, we've got contextual relevancy. So this metric looks at each document the retriever pulled and it asks whether this was actually helpful for the user's question. So you go node by node, you check for relevance, and then you calculate the proportion of good versus noisy context. High contextual relevancy looks like clean, sharp, and less confusing input. Let's shift to agents for a quick bit. A system that use tools. So we need special metrics for them, like tool correctness. So if I'm asking, say for example, GPT to generate me an image, did it actually use its image generation or did it generate an image in ASCII? That is what we have to ask. And also task completion. So did it actually finish the goal or did it leave it in between? Let's zoom out back to the big picture. So in the next 6 months, three things will define the best AI teams: hallucination testing, traceable agents, and eval-driven iteration. Like, this is what separates demos from stable products. And trust, cost control, and UX all hinge on having the right eval stack. So a great eval strategy also includes human in the loop components, especially for high risk areas. So humans have to label 100% of the high stakes output, and this cuts hallucinations almost by 40%. Feedback loops, we have to tag failure cases and we have to retrain them weekly because one compliance AI reduced the update lag by 80% and uncertainty sampling. Models that admit I don't know, they reduce bad decisions by 31%. So you want your model to admit that. The takeaway is if we combine smart evals and if we combine smart humans, we can create a much more trustworthy AI pipeline. Last note, like evals also the cost, but they also impact the efficiency. So all of these, like this is a visual that I got from Reddit. It asks like per dollar, what will give you the best bang for buck in your evals? So as you can see, it marks DeepSeek R1, Gemini, and Llama as the best ones. So when you optimize, you don't just optimize for accuracy, but you also optimize for burn rate. And that's a wrap. I think we've covered everything from why LLM evals matter to how they work, how the tools exist. So they're the key to safe, reliable, and high impact AI. Thank you so much for listening. And I'd love to hear your thoughts about this topic.
Nice.
Yeah, thank you so much. And
Um,
it was very
thank
informative.
you, Giant.
Yeah,
Agents,
thank you.
it was
Uh,
very interactive.
Yeah, great,
Okay,
Jen.
yeah,
Great.
I have two questions.
okay.
Um, One is, can you share the material with everyone so that we can read it
Yeah, obviously.
calmly ourselves?
Yeah.
Two, um, given all this, you obviously put a lot of thought into this. How would you use it in our company?
So like for example, Sunny is writing a LinkedIn scraper, right? That is a RAG tool. So for evaluating this, we could, use the RAG metrics that I discussed. And apart from
I
that,
will like
even the
to add.
chatbot that I am like doing right now, the chatbot also needs to be evaluated on based on its responses. Like the prompt that we're giving, we want to see if the prompt works or if it doesn't work.
Yeah,
So
Okay,
and
so it's mostly for evaluating prompts.
yeah, and yeah, like for now, like we can use those metrics for improving our AI score, right? And and also, like there's a like as Jayan discussed, like a context relevancy hallucination score that would help us to even like test whether our prompt is good or not, whether the LLM is following our prompt or not. All those things can be tested using those LLM-as-a-judge metrics, right? And later on, like we have to integrate some chatbot in our platform. So they so there also we need these metrics to evaluate whether the generated answer by the LLM is correct or not. So there we will be using all those metrics right. Yes.
Clear, thank you.
Fundamentally, any LLM generated or AI generated output need to be evaluated, right? So, and we have so many workflows which are generated, the response is generated by LLM, whether it is scores and justification of the AI scores, or for investment memos, or even the any chatbot, right? This AI avatar. So all these responses are generated by AI, which need to be evaluated. And as I think Jen mentioned in one of the earlier slides, yeah, if we don't evaluate over the period of time, there's a concept of model drift, which is eventually the performance of the model keep on degrading, because as the new data or as we fine tune or improve new model, there would be a shift on which the model it was trained, then the new test data. So let's say the, maybe there is a diversity in that data. I initially tested the model, or I initially trained the model for different demography, and now the demography of the data has been changed. So basically, the distribution of the data will change, which eventually led to the degradation of the model, and that had that we need this external system or the evaluation system, which keep on checking like how if we are degrading and what then need to be fixed. Yeah.
There. So as a follow-up question, then, does the evaluation point you towards what is going wrong, or does it also provide or suggest a fix?
it generally points what is
No,
going wrong.
yeah, great question. I think it just point to where it is going wrong, and then it has
Okay.
yeah, we need to maybe do some reverse engineering, find out like how we can fix it.
Okay, clear. Thank you.
I mean, it's like it also gives scores based on the generated output by LLM, and based on the scores, we decides whether we should consider those scores or not. Like for the hallucination part, it gives scores between 0 to 1. Like if a scores is closer to 1, means the model is hallucinating a lot. Like it's giving very wrong output. Like it's deviating much than the actual output, right? So that also give us insight to whether model is like how model is behaving, right? Yeah.
Yeah. And
Mhm.
I think that's what we're also discussing, right? So, Sunny, we can also use it as a way to for confidence level. So, if the
Yeah.
hallucination score from the model is 0.53, we can say, okay, we are one is like it's really hallucinated. Okay, so vice versa. So then we say, okay, it's 47%. We are confident that this information is factually correct.
Yes. Yes.
Something like we can introduce
Yeah.
confidence score in
Yes.
our LLM
Yeah.
generated output.
Yes. Yes. Like in this slide, you can see like we can also pass threshold. Like we can set some threshold to filter out like whether we need to consider those generated output or not. That- Like here,
Yeah.
like the
And
Yeah.
element
then
generate
this
out.
threshold setting, I think it would be manually evaluated and iteratively, right? So over the period of time, we'll start with some threshold and figure it out how we can iteratively improve and get to the optimal value eventually.
Okay. Yeah. That means